Hello everybody, my name is Moshe Zadka. My website is cobordism.com, where you can find everywhere of reaching me known to humankind. And today I want to talk to you about the Garden of Forking Path. What do you want to call today? I want to start with an acknowledgement of country. I live in Belmont in the San Francisco Bay Area, which is the ancestral homeland of the Reinventing Shoaloni. And I want to talk about how do you do the same thing? And classically, we have an answer for that in Python, which is polymorphism. The easiest example to think about is the .write method. You can call the .write on what you get from calling open, the built-in open. You can call .write on what you get from socket.makefile. You can call .write on io.string.io. And we think about them as the same write. We think about them doing the same thing. And let's dig down. What does it mean that these .write do the same thing? Because they don't do the same thing. Right? One sends the bytes across to a different computer, one saves them to the file system, one puts them in the memory buffer that's gonna go away when the process goes down. So in what sense is the same thing? And let's dig into that a bit. We start with thinking about compatible return values. Maybe we don't care that much about the arguments because, as we'll talk later, sometimes when we say the same thing, we actually mean that we can give it slightly different arguments. And definitely the self argument is going to be different in all these cases. But the return values are definitely all compatible. Right? When we call the function, then we get, but in the case of .write, we get a number, which is the number, in general, the number of things you put in, like the length of the character string or the byte buffer. And you know, if you have written actual Python code, you probably have never looked at the value of .write. So the fact that it always returns a number and it's the number of things that it sent, that's not interesting. That's not what we hinge the concept of the same thing on. And there's a vague notion that they all have the compatible semantics. For example, if we call .write with something and then the rest of the thing, and we call .write with the whole thing, it's more or less the same thing. And these are very vague things, and this will be a theme in the talk. The definition of the same thing is never going to get any stricter. It won't get any stricter because if it could have, we would have solved it for .write, which has existed since like Python 1.4. And we still have this vague notion that it's the same .write, and we have never tried to formally define it. So the main thing I want to say here is that I'm not going to give any better definition of the same thing because I'm not going to do better than the whole Python world in 20 years. But we will give a concrete example of the same thing, which is certificate validity check. We want to check if a certificate for some service is valid. That's at least a concrete thing. We want to give a report on the validity maybe. And what kind of services do we want to look at? We want to do the same thing. We want to check whether the certificate is valid for all these different sorts of services. So I'm not going to write a whole infrastructure for checking a certificate. So instead I'm going to be optimistic. Because otherwise this would be a very different talk about the vagaries of TLS and cryptography. So I'm going to assume that the certificate is already valid and someone took care of it. But we will use this function in the rest of the talk to do things. And because of that, I want to say that this is a connected socket. So when you get to that function, you can assume that the socket is already connected. Let's try and test it manually. We create a socket, we connect to it, we check the certificate. Looks good because it always looks good. We are good to go. Let's start writing the nice interface now that we have a good infrastructure. The first version is probably straightforward. We want to support IPv4 in a port because most services are specified with IPv4 in a port. This version will accidentally support name, and that's kind of be something we'll look into later. So we call check certificate with an IP and a port. We connect the socket to the port. We check the certificate, all looks good. We return an iterator, which is going to be interesting later, but if you remember what I said in the beginning of the talk, we want to have a compatible return semantics. Sometimes there might be multiple certificates available for a service, so we want to already be able to do that, so we're good to go. We have a good function. And this is a good first version. A lot of people have IP ports that they want to check the validity. Let's give it to them. It might be an internal library that you write inside your company. It might be an open source library. Whatever the case may be, you publish it via the internal publishing mechanisms or via PyPI, and people start using it. And it's good, it's great, it works well. That's not good news, because we all know what happens when something works well. People start using it, and then they start having feature requests. And the feature requests come in. Our users want more. They want a name that resolves to multiple IPs. Remember, this kind of supports a name, so they already put like names. And then when they had a name that resolved to multiple IPs, it chose the first one that gets from ghost source by name, which is sometimes random. Not a great experience. They want us to have proper support for multiple IP name. There's always these people with like, our data center internally is all IPv6. I don't have IPv4. Can you have something for IPv6? Yes, that's a future. Of course you should have that. We use SRV. Can you look up the record in an SRV DNS and connect to that? That sounds like a reasonable request. A lot of things put things in SRV. That's a reasonable way to lay out the data center. They want to do named ports because it's kind of annoying to write 80. It makes more sense to write HTTP or HTTPS. All reasonable. And since these are all reasonable requests, and people tend to implement them, and we probably got PRs here and there, and we merge them all because we want to be good people. And we got this. This function doesn't implement everything that I specified, because if it did, I would have no room for it on a slide. Even so, it already falls off the side a little bit, as you can see. And even so, with allowing myself to implement only partially for the sake of teaching, and allowing myself to cut off some parts that are probably like easy to guess, but still not a great experience to look at. And I also had to do some pretty ugly formatting to kind of shove it all into the slide. Black would have had a field day with that. And it still looks bad. This is not something you want to maintain. This is not something you want to look at. It does work, right? So, it works for name stuff and it works for IP. So great. Do you really want to maintain this long term? Do you think anyone else will want to help you maintain this long term? So we decide we want to do something better. And luckily, Python is a great language. It has really, really powerful dictionary objects. You just create it and you can do all kinds of lookups, and it has all sorts of methods that help you manage it. Functions are a first level object. You can put them in dictionaries, you can put them in lists, you can do whatever you want. Surely we should be able to use all this great infrastructure to make our functions look a little better. So we roll up our sleeves, we learn about dictionaries, and we decide to write something that will work better. So this is the third version. Right? The first version was the one that only supported IP and kind of names. The second version was the one we don't talk about ever. And this is the third version. And the core function is pretty easy. It was really easy to fit it on a slide because it does nothing. It just dispatches to whatever is in the dictionary. And we already know what to dispatch if someone tells us the IP. We already wrote that function. So let's put it in here. And with a little bit of gunk, a little bit of improvisation, and a little bit of set default, we even got a decorator. So we can decorate it and say this dispatches based on name. So check certificate by name, and then we do the get host by name, and we check all the IPs. Everything looks great. Excellent. The implementation is wonderful. The interface is not great. Look at this. This is an interface that only its implementer could love. The previous one had an ugly implementation, but the interface was pretty cool. You just give it stuff, it figures it out. Now we have to give a string name. It's not obvious which strings are valid. If you slightly misspell a string, instead of getting a reasonable error, you get key not found. It's not great. But the implementation is nice. So we have a trade-off. We can have a nice interface and implementation, or we can have a maintainable implementation and on the interface. Is that the only two options? Well, there's one more thing that Python has. It has PyPI. I haven't checked yesterday or today. Last time I checked, it had a few 100,000 packages. For now, for all I know, it has over 1 million. A lot. A lot is definitely a good description. It has a lot of packages. Surely one of them could help us. Surely we're not the first people to have stumbled into this problem. And yes, we have a good package. It's called variants. All we need to do to the previous check certificate was give it a little tiny decorator at variants.primary. Barely an inconvenience. The rest of the implementation is the same, so I'm not going to talk about it, but with that little thing, now we can explicitly say that if you want by name, very similar to the decorator we had before, that we kind of improvised with the default, check certificate by name, and then, the same implementation that we had before. So the only thing that changed was the decorator. Even the decorator is a little bit nicer. But the implementation, that looks nice. Check certificate dot by name, name example.com, check certificate. This looks great. Great interface, great implementation. Everything is super explicit. And surely we are done, because what can be better than that? It's explicit, it's good interface, it's good implementation. But I said the word explicit a few times. You might be thinking, that's great. Then of Python. Explicit is better than implicit. How well does Python observe the then of Python? Let's look at the function str. We can call str on 5, on the string 5, on the fraction 5/1, on the decimal 5, and they'll always give the string 5, and you just had to say string. You didn't have to say string from integer, string from string, string from fraction, string from decimal. String just figured it out. It doesn't even look like a method. It looks like a function. This is great. Can't your check certificate look like that? This sounds like a great interface. You can call it implicit, but really, if Python does it, it's probably okay. And you don't even have to look far. You don't have to look otherwise outside of PyPI, because Python has another awesome thing, which is a great standard library. And in the standard library, it has a pretty cool module called functools, and in that module, there's a pretty cool function called single dispatch. We'll decorate a function with single dispatch, and when we think of single dispatch, we really should be thinking of methods. And if you think of methods, what should a method do on something it never was implemented? It should probably not be implemented. If someone gives me a list or a dictionary to check a certificate of, I probably want to fail with a nice error. That's probably the best thing I can do. So let's fail with a nice error, which is a not implement error, intended exactly for that use case. And now that we have that function, we will define a variant called auto. We can't use a decorator on that because that will not allow us to decorate with this function. So we have to do a little bit of hijinks to get everything in the same place. But the reward. We can register based on type. We can register for str name port, because if they give us an str, we want to assume that it's a name and resolve the name. Well, how would you express an IP? We thought that an str could also be an IP. But Python has an object for that. It has an IP address. We can be explicit instead of in the name in the object that we give. We can explicitly convert it to IP address. And if someone gives us an IP address, we know what to do. We convert it back to a string, which is a string representation of an IP, and we call check certificate that will check it by IP. So now, this sounds pretty cool. We have implemented. We also made it as an explicit variant for IP for the people who do want explicit variants. Excellent. This looks great. We give it a string, it does the right thing. We give it an IP address, it does the right thing. And if we want to be explicit, we can be explicit. Once again, you might think we're done. We have explicit type-based dispatch. We have explicit name when we want to call the specific function. So what else would we need? Well, there's one other thing that we might want to do, which is to say, what if I don't know exactly which class I have, but I have the interface for it? Surely I should be able to dispatch based on the interface. And unfortunately, single dispatch will not help us. Once again, we have to look out to PyPI. And when we get an interface like that, which clearly we should be able to get an IP from that and connect, we want to be able to do that. So we get a library called reg. The reg library allows a lot of power. And now that we have a lot of power, we know what to do. We can abuse it. So let's abuse it. Unfortunately, the reg library by itself will not dispatch to interfaces either, but it allows us to completely override every single algorithm it has in dispatching. It has a class index, which basically is how it implements type-based dispatch, very similar to how single dispatch does it. So we can call up to super and then also return all the interfaces. This is how reg thinks of the world in terms of indexes. It tells, okay, here, what kind of things do you want to be dispatched on? I'll find the first thing that I can dispatch to and give it the call you the right function. This looks great. Unfortunately, the match index by itself already makes a class.interface index. Not to worry, we define our own match instance that gets a predicate for match instance and overrides the class in interface index and returns a new predicate. It looks nice so far. Now let's use it. We want to say reg.dispatch, and we want to say you want to match on the type of endpoint. And the first thing we want to do is be compatible with single dispatch. And for the same reason, we raised not implemented error in the root function. And when we get an str, we want to call get by name. When we get an IP address, we want to call get IP address. Everything works. But if this was all we had, then we could have stuck with single dispatch. So let's dispatch based on the interface now. Well, if we get an iaddressable, we can guess what we need to do. We'll get the IP from addressable.ip, get an address, call it just a get certificate by IP. Looks great. Very straightforward. Can we use it? Well, before you can use it, you have to define something that actually implements the interface. A real implementation for something like that would probably be more interesting. It would look it up in a database or in a text file. But let's have a simple implementation so we can test. So we have a known, and known just has an IP and returns it. So this looks pretty straightforward. But notice it is not an IP. You do have to get the IP from it somehow. So let's look at how it works. We notice that known was defined after all of the dispatches to reg was already done. At that point, known didn't exist, but it implements an interface, the iaddressable. And because of that, when we ask reg to dispatch based on X, and because we did all the class and interface indexing, it gets a certificate and all is right with the world. So that looks great. And again, we are very, very happy. So what's the next step? Well, we can still dispatch based on type. So we're good with strings. We're good with IP addresses. And this is pretty cool. So now we wrap it up and we decide this is a great library to publish. We publish it, great interface, get implementation, everything is cool. And you'll notice that every single function fit on a slide with black compatible formatting. And this is important. You want your code to be maintainable. Fitting on a slide is a very strict test, but your code is also probably going to do more complicated things. So this is a great pressure on us. Much better than looking at a 200-line function in your editor. So what are the takeaways from all of it? First of all, avoid those long if-elif branches. Usually when you have these if-elif branches, they'll start kind of be a bit more interesting. A little bit of try except, a little bit of for looping, some action going on. There'll usually be kind of this kind of spine of if-elif going throughout the function. That should be the warning sign. This is not great. If you have 4 if-elif, you'll probably need more. There's no reason that like only 4 options will be there. And it's going to go bigger and bigger and bigger until it's completely unmaintainable. Avoid reinventing wheels. Our first attempt to just say, Python has great dictionaries, Python has great functions. Yes, it does. But our job was to write a certificate checker. Our job was not to write a dispatching library. Because of that, we did a poor job writing a dispatching library. Don't do a poor job re-implementing something that exists. Go out, look at PyPI. I've specified 2 options here. There's more. There's multi-dispatch, and there's probably other options that you haven't even heard of. PyPI is pretty big, and I probably haven't heard of most of it. Variant is explicit. This is great for the times you want to explicitly say which path you want to take. Single dispatch is exactly the same algorithm as method dispatch. If you understand method dispatch, including the MRO for multi-inheritance, all of that, you understand single dispatch. It uses the same algorithm, but allows you to add methods retroactively, which is a great option in many cases where you don't control things like str and IP address. Reg is super powerful. You can do whatever you want with it. The downside is it's super powerful, and you can do whatever you want with it. So if you do decide to use it with care, think carefully, document carefully, apply a little bit of thought and mindfulness and think of what can go wrong. I think the coolest thing here is that they all play nicely together. I managed to create one check certificate primary that had all these things hanging off of it. If this was an actual library, the only thing in under all would be check certificate. I wouldn't have to export a lot of options. They will all be encased in one thing. They all play nicely together. Sometimes you do have to encourage them, just like with kids, to play nicely together. But as long as you put in the right encouragement and you help them, you can do it. So with that, I want to call on you to go forth, implement all kinds of guarding the forking path in a way that's great to implement and great to use. Thank you all, and I hope you enjoy the talk.